thank you all for joining us. We're going to kick off in just a moment. This webinar will be recorded, and so if you feel like forwarding it to a colleague, do so, because I'm sure they will find it just as valuable as you will as we start kicking off. So today we are going to be talking about voice enabling your AI agent. I am absolutely delighted and honored to be joined again for maybe the third time or fourth time now, Scott. Me and you have been on these sessions quite a few times over the last number of years. I forget how many it is now, but
Yeah, it's been a few. Love hanging out.
exactly. So Scott Stevenson is the CEO of Deepgram, and we also joined by Quindler Hultman Kramer, who is the CEO and co-founder of Daily. Quinn, hello there.
Thanks for having me. Long time listener, first time caller.
Nice one, nice one. It's a pleasure having you here as well. And yeah, as I mentioned in the beginning there, what we're going to do in this session, we're going to go through the specifics of how you can voice enable your AI agent. Obviously, you must be living under a rock if you haven't seen how much attention AI has been receiving since 2022, when OpenAI really kind of popularized the transformer-based language models, the large language models that we know and love today. And since then, everybody has been experimenting with how to turn these technologies into production-ready assistants or production-ready AI agents that are solving real problems, real user problems, real business problems. And for a lot of that time, a lot of the attention has been placed on text inputs. ChatGPT is predominantly text-based, although we saw recently GPT 4.0 how they are definitely trying to position ChatGPT more as a voice with more voice capabilities, more like a voice assistant style kind of thing. Google Gemini, very much similar. And over the years, really, for those of you that don't know, for those of you that are just getting into AI now or over the last 2 years, voice has been something that's been knocking on the door of widespread consumer adoption for a long, long time. You could take it all the way back to the 1930s with IBM's Shoebox, which was the very first device that was able to recognize speech. It was only able to recognize like 10 numbers, 0 to 9, and it was only able to actually do very, very basic tasks like what is 2 times 2 or what is 3 plus 4, things like that. But over that time, since then, since the 30s, even before AI was even a thing, which came around about in the 50s, even before that, we've had machines that we can talk to. And over the time, since the 30s, it's been getting better and better. In the 80s, we saw the very first voice-enabled toy. In fact, it was the very first consumer-facing voice-enabled device, which was Julie. It was a child's doll that was available in the US in the 80s. Nuance obviously have had a large footprint in voice over the time, and they made kind of dictation really popular in the 90s, and they were responsible also for building some of the early kind of phone systems that we all pretty much hate today. And all the while, voice has been getting better, voice transcriptions being getting better. Then we had the round of assistants, the Alexas and Google Assistants, and then we started to really see what can happen when these things become able to do things for you. And the issue that we've had over that time, the technology has been getting better and better and better over the years, and now we can do things like understand far more accents, the accuracy is far better, the latency is far better, far more languages we're able to understand a lot more. The voices on the back end are tremendous, and we're going to show you some examples today, not only of the transcription stuff working to enable your AI agents, but also the voices that are speaking and coming back, which is crucial because with a voice interface, the actual voice is all you've got. There's nothing else but that. And so it's really crucial to have something that's really human-like, really natural, and really effective and authentic. And so the thing that's been missing in all of this time, though, however, is the capabilities of the AI models. We've come from the NLU world with intent-based NLU systems and rule-based NLU systems, and all of those things have been really clunky and really terrible and don't really lend itself to really great experiences. Now we're in a world of generative AI. We've got generative technologies, large language models, vast language understanding, and so we're really at a place now where we can really start making this stuff work properly, and that's essentially what today is all about. And so I'm delighted, as I said, for Quinn and for Scott to join us. And before we get into this, I want to do one very quick poll. So if you'll indulge me, everybody, for a quick second, it's just interested to learn a little bit about your level of experience with large language models and generative AI. 2, your level of experience with voice assistants or voice AI agents in general. And then three, what stage you're at in terms of deploying your voice capabilities. So first question, what is your experience with large language models and generative AI? Are you a beginner, learning? Are you a novice, which means you've dabbled a little bit? Are you an amateur, working on one or two projects? Are you established? You've been doing this for a couple of years. Or are you professional, which is that this has been your job for quite a while? On the voice AI side of things, similar kind of suite of questions. Are you a beginner, a novice, an amateur, established, a professional? And I've also got legend in there as well, because there's quite a few people who may have been doing this, Quinn and Scott included, for quite a while. And so if you are decades in the game, then I would consider you a legend. And number three, what stage are you at with deploying voice AI generally? Are you just generally interested? Are you here to learn a bit? Are you researching something for a specific project that you've got lined up? Have you started something, some kind of proof of concept? Have you shipped a working voice AI agent, or are you trying to scale up? And as you're voting for that, it'll be really great to hear firstly from you, Scott, and then from you, Quinn, in terms of a little bit about yourselves. Introduce yourselves and let us know a little bit about who you are, what you're doing, a bit about Deepgram, Scott first.
Sure. Yeah, I'm Scott. I'm CEO of a company called Deepgram. We're a voice AI company that builds speech to text and text to speech. And we put together an entire system so that folks can talk to computers like we've always wanted to. And latency is a really big deal for us. Keeping the cost reasonable is a really big deal for us because we see this technology scaling massively. And so it's got to be fast, it's got to be interactive, and companies have to be able to afford it to actually build these interfaces. Glad to be here.
Thank you very much. And Deepgram has been one of the really early adopters of speech technology, and actually out, really out in on the kind of bleeding edge of some of this stuff as well. So it's brilliant to see you thriving. And as I said, me and you, Scott, have been going back quite a while, so it's brilliant to see the progress Deepgram has made. It's unbelievable. Quinn, tell us a bit about yourself and about Daily.
I'm Quinn Laholman Kramer. I'm one of the co-founders and CEO of a company called Daily. We make real-time infrastructure for audio and video, and now increasingly AI. We've been working with Scott and Deepgram for a long time. We've known each other probably since about 2016, and I totally agree, Kane. Deepgram's always been way ahead of the curve here, and Scott's one of my favorite people to talk to about both the technology and the use cases here. At Daily, what we do is we give you infrastructure and SDKs that lets you embed real-time audio and video into any app or website. We have lots of infrastructure all over the world. We have SDKs for web, iOS, Android, all the platforms you'd want, and you can build something like this Zoom webinar in Daily using us to power your audio and video layer if you want to. We integrate tightly with Deepgram for some of the speech capabilities we've offered our customers for a long time, and our fastest growing use cases are voice AI broadly considered, and especially the new conversational AI stuff that you were describing so well in the intro.
Nice, wicked. Um, yeah, it's really interesting, and I'm super glad to see that there's real interest in this kind of stuff. Going to the poll, we have most of the people in the poll, actually, most of the people who are attending today, 50% of such would class themselves as amateur when it comes to large language models and generative AI in general. So that means that they've worked on one or two projects, so they've got a little bit of field experience. 20% or so are beginners, so they're really just learning out here to understand a little bit more. And we have 20% or so who are either established or professional, so they've been doing this for quite a while. So a mixed bag there. And then in terms of their voice experience, again, 50% of the audience have worked on a few voice projects, so they would consider themselves in that kind of amateur sort of category. More, so it's slightly less are been doing this for a while. We've got one legend in the room, apparently. Shout out to whoever you are, and the rest kind of beginner and novice. And then in terms of the kind of stage that they're at with deploying voice AI, there's 20% or so that are generally interested, 20% that are researching for a very specific project. And so for you guys and girls, I think you're going to learn a hell of a lot over this next hour or so. 40% are actually have started a proof of concept. And so that's really, really interesting because, as I said, as we go through this webinar, you're going to see some demos, you're going to see this stuff in action, you're going to learn a bit more about how you can actually deploy this stuff. And so that'll be really, really valuable for you. And 20% or so have actually shipped something or they're in the process of scaling up. So I think we've got a really good bunch here. Maybe the question to begin with for those that are beginners and just learning, and then we'll move on to the more advanced stuff. But Scott, maybe we'll start with you in terms of why would somebody look to enable their AI agent in the first place with voice?
Yeah, well, I think there's just kind of an innate desire to do it too, but there's also just tons of value. But the way I like to think about this is the first, well, there are flashy things to go after, but there are also just like purely like work that nobody necessarily wants to do, and that's probably the place that you start first, actually. So think if you're a small business and you came in the morning at 8 a.m. and you closed up shop at 6 p.m. But people are still calling you in the evening. um, do you want that to just go to voicemail or have somebody not answer it? Or would you rather have, a nice personality on the other side of that that says, oh, sorry, we're not open right now, but I can answer questions for you. I can do this, I can do that. I'll take an appointment for you tomorrow, that kind of thing. I think everybody would say, okay, I want the second one. And this just, that's just one example, but there are tons of them. But I think that we as a humanity, as people, we've only had artisanal intelligence up until now, and we didn't have like the ability to scale intelligence outside of a human sitting down, drinking their coffee in the morning, doing all the stuff, and then going out and doing that intelligence work. But now you can hire a machine to do a lot of this work for you that then frees up people to do other more valuable things. And so this is something that is, close to my heart, where I think about this is going to massively increase the productivity of the world. And when the productivity of the world goes up, everybody benefits over time. And so this could be call center use cases. It could be answering the phone. It could be just you're taking orders at a drive-through, and all these quick serve restaurants are understaffed. Inflation has gone insane. It's really hard for them to find people to work. But some of these jobs can be automated and free up folks to focus on the things that only you could do in the physical world, et cetera. So a lot of use cases out there, and but also I think just a lot of, it's one of the first things people think about doing with a computer, going all the way back in time, like you mentioned, Kane. As soon as you start to see some of the computational things happen in your first, in your life for the first time, you think like, whoa, can I talk to it? How smart is this thing, et cetera. And now you're able to do that.
Nice. Quinn, any further thoughts on that, like in terms of reasons why people would consider voice enabling their AI agents?
Yeah, I think about it as sort of three phases. And with generative AI, everything is developing so fast, so they're overlapping each other. But the first phase is, can we do better things we're already doing? So a bunch of stuff Scott talked about clearly falls into that category. The small business having a good answering machine is, a non-trivial value add. It's fairly clear how to build it today. That's going to get rolled out. All of those things are going to get rolled out quite quickly. I'll show a video in a minute of a healthcare use case, patient onboarding, patient intake via voice. So, we have to fill out a bunch of forms every time we go to the doctor's office. We don't like doing that. We generally don't do it very well because we don't like doing it. It's actually kind of hard to process those forms in a good way. They're not very kind of meaningful in terms of how the information is gathered. We can massively improve the one small part of the healthcare system with LLMs you can talk to, and you can generalize that across healthcare and then across a whole bunch of other sectors. The second phase looks like leaning into things we wish we could do but can't really do today. My favorite use case there is a personal tutor for every child in the world for every subject they have in school. We are not going to replace human teachers, and we don't want to. But I think every bit of research that's been done over the past 100 years in education has shown that one on one attention makes a difference to every student at every grade level, at every ability level. And we are now within sight of giving every kid in the world a one on one tutor for every subject available all the time, affordably. I think we're not talking about that enough. I think that's incredible. And one of the drivers of that is going to be voice. It's not the only one, but you're going to talk to that tutor as a primary modality. And then the third phase are the conversational use cases that become our new social world. And Scott has talked about this a bunch, so I don't want to steal from him too much. But we are talking creatures. Humans are storytellers and story listeners, and we love to talk to each other. I think it's obvious that we will also love to talk to well-designed machine intelligences. That's a little farther out, but you can see the glimmers of it if you're working in this space. And just like big parts of the internet are additive to our lives in terms of giving us access to sort of global information and communication, we're going to extend that to this conversational intelligence era that Scott described.
Definitely, definitely. And there's a few things as well that for those who've said in the poll there that they've got experience building AI agents. One of the really interesting things about voice enabling those things is it also increases both the availability of it, which means you don't have to be sitting with your phone in your hand or sitting on your computer, and it also increases the accessibility of it as well. Because if you can talk to it, then you don't need to use keyboards and mice and things like that. So there's an accessibility angle to it. It also, I think, opens up new use cases that maybe you maybe wouldn't have thought about before. Let's imagine that you're doing something like you're out for a run or you're washing up or you're trying to get the kids ready or you're not in a situation where you're sat down at a computer typing like a big use case for ChatGPT is. Being able to take use cases and bring them onto devices like earphones and watches and smartphones and apps, but without needing to actually physically use them, opens up, I think, new use cases and yeah, definitely increases the availability and access to these agents as well, which is all part of supporting that kind of move towards ambient computing and software being in the background while the AI is kind of more on the interface layer.
One of the things that our healthcare customers say to us all the time is, if I can focus more on my patient when I'm in the room with my patient, that's a big deal to me. I got into healthcare because I wanted to help patients, not because I wanted to like sit at a computer and take notes while I'm trying to also pay attention to the patient. And this stuff that we're collectively building and the really great models from Deepgram are now good enough that you can trust them to do the note taking for you. Then you can feed that data into an LLM, then you get a bunch of downstream benefits. But the primary thing the healthcare providers say to us is, I want to focus on the patient.
Nice. And what are some of the use cases you've been seeing recently then, Scott? As I said in the intro, you've been doing this for a long time. Deepgram has been, really leading the way with speech recognition and now with synthetic voices, text to speech, which we'll get onto in a bit as well. So what are some of the kind of like predominant use cases you're seeing out there? I think we've alluded to a couple, but is there any others that we haven't covered?
I think there's a few eras in the modern like voice AI epoch here, where so Deepgram has been around for almost 9 years now, and starting for probably the first 5-ish years, most use cases were just a batch mode analytics based. So that would be you record the entire thing, you don't really do anything in real time, and transcribe everything and try to figure out like what kind of audio was that. So for instance, like for a call center or something like that, why did they call in? What topics were talked about? Were competitors mentioned? That kind of thing. So analytics based type use cases. And by the way, those had existed before, and Nuance and other services were serving that area. But the modern end-to-end deep learning based speech recognition like really like changed that. You go from around that time, 2014, 2015, 2016, maybe 65% accuracy, 70% accuracy, something like that, to now over 90. And it totally changed how all of that worked. But that was one era, and it was how I would describe that as mostly call centers, mostly analytics. And then around the time, it actually started a little bit before COVID, about 1 year before, but when the pandemic came around, um, then that really supercharged it. There was a real-time assist push. So you can kind of look at it in phases now. It's like, oh, batch mode, record, it's only the recording. Then folks are dipping their toes in the real-time world, but they don't want to hand the reins over yet. So it's just a human, and there's something listening in and helping that human in the conversation. So it's a human to human conversation, but AI assisted. And then now, by the way, the analytics is still going, still growing, but then you add in real-time assist. And then now you add in full AI agents where you have a speech to text type system, you have a text to text type system like an LLM, and then you have a text to speech type system where you can complete the loop and have entire conversations without a human involved. You don't necessarily have to have no humans involved. You could have a human listening in, and like correcting the machine, and that's also a stepping stone along the way. And we see this across many areas, food ordering, healthcare, call center, like as mentioned. We see it in meetings. We see it in retail. We see even just like the government trying to get more efficient with healthcare, like Medicare, providing Medicare services and that kind of thing. And so, yeah, it's being adopted all over the place. We're a horizontal company, and so we have a lot of different types of customers. But in general, the thing that's happening right now, the big growth area is real-time agents that where they need low latency, high accuracy, a nice human sounding voice. And that's essentially adding a new UI to all types of systems across tech.
Nice, nice. And Quinn, you alluded earlier to some demos you're going to show us. Maybe we can start getting into a bit of that now in terms of what does it take to voice enable an AI agent? What's the steps that we go through? What are the technologies that we need? Scott alluded to some there in terms of the speech recognition and the synthetic voices on the back end, but obviously there's going to be a lot more to it than that. So maybe you can walk us through some of the process and then we can see some examples of some of the stuff that you and your customers have been building.
Sure, I'll share my screen if that's okay.
Go for it.
Here we are. So this is what we want to do at a high level. We want somebody on a phone or a computer to be able to talk to a powerful AI agent in the cloud. It's a little bit simplified view though, because what it really looks like by the time you glue a bunch of pieces of technology together is something more like this. And we started building these voice driven agents kind of in a real way about a year ago. So we climbed up the learning curve to figure out not just for what Daily has traditionally done, sort of the live audio and video with transcription and recording, but also these true conversational experiences with LLMs. What do you need? What are the pieces you need? Turns out you need most of the things on this slide. And we'll dip down into a demo and then sort of come back to some of these pieces in a minute. But I always like to start with a demo. And I really do like this healthcare use case because we all have a sense of what it's like to be asked to fill out several forms every time we go to a healthcare appointment. This demo pulls together a bunch of those pieces that are floating around on that previous slide.
Hello, chat. My name is Jessica, and I am with Tri-County Health Services. To ensure your privacy and to confirm your identity, could you please provide me with your birthday, including the year?
Yeah, it's January 1st.
I appreciate that, Chad. Can you also tell me
Oh,
the
sorry.
year?
Yeah, 1983.
Thank you for providing your birthday, Chad. Now, could you please list your current prescriptions, including the medication name and the dosage for each?
Yeah, I take lisinopril and also gabapentin.
Great. Could you please provide the
Oh,
dosage?
yeah. Sorry, 10 milligrams and 100 milligrams, respectively.
So I think what you can see there is how valuable the natural experience is. If I didn't answer the whole question, the LLM is smart enough now to come back and ask me again. It's infinitely patient. You can script it so that you know exactly what information you're trying to collect, but the conversation is still open-ended. You can interrupt the LLM. That's a Deepgram voice, by the way, and it's also Deepgram transcription of the audio coming into the bot. And the latency is quite good there, even though we're doing tool calling to interface with an external system. And that was several months ago, and that recording. And now we have even faster LLMs that are very high quality, like GPT-4o. And the sort of every little piece of the pipeline continues to get better week by week. So it's exciting times for building this stuff. If we dive back into that sort of slide and just look at what we want to happen in that little cloud, like a shape where the AI is running. The core things we're trying to do in almost all these use cases are some kind of natural language processing of the voice coming from the person, phrase endpointing so we know when the LLM needs to take action. Then we need to prompt the LLM. Then we need to generate some voice output. We're hiding a lot of complexity here, but it's useful to think about a pipeline. That's how we talk about it a lot when we're getting people sort of up to speed on how to build this stuff. There's a pipeline that involves the speech, the LLMs, often multiple deep learning models are involved, and you have to sort of get the data through that pipeline in a very low latency way. Here's some code because I always like to show code. We won't spend too much time on this, but this is a fully functioning voice bot. There's about 50 lines of code here. There's some Python imports that I didn't include in the screen, but other than the Python imports, this is a full working conversational AI bot built on a library that we released in open source called PipeCat that makes it easy to build those pipelines I was just describing. And if you sort of go through this code in order, you can see all of those pieces. There's the Deepgram TTS, there's the Google LLM, in this case, Gemini Flash in this code, which just came out 2 weeks ago and is a fun model to experiment with. And then you put everything together into this pipeline that processes the data in order and just sort of runs in a loop. If you're a programmer, there are lots of loops in your life. This is another loop you can build a bunch of cool stuff with. I actually just want to show you that exact bot running for about 30 seconds. So this is the code we just looked at on screen.
Hi there, I'm a large language model ready to chat and make you laugh.
Oh, thanks. I'm excited to talk to you.
That's great to hear. I'm excited to talk to you too. Let's make this conversation a real hoot.
Let's do. In fact, let's bring another bot to this call, this time using the GPT-4o LLM and the Deepgram Angus voice.
Would anyone like to hear a joke that's fresher than the guacamole at your favorite taco joint?
Oh, I love a good joke. Let's hear it.
All right. Why don't scientists trust atoms anymore? Because they make up everything.
Turns out when you ask an LLM to tell a joke, probably about 10% of the time, all of the state-of-the-art LLMs will tell you that Adams joke, which makes me laugh every time in a different way because I ask LLMs to tell me a joke a lot as voice test hooks. So I have heard that joke a lot. So that's two different models running in completely separate processes, communicating only via voice and glued together. I mean, the interface between these two agents is the Deepgram transcription and the Deepgram voice output, which I think is also kind of very conceptually interesting as we think about how to build all these systems in the future. Voice is not just going to be a human to human and a human to agent interface. It's also going to be an agent to agent interface. And I think we've only just started to scratch the surface there. Also, you can see how good the LLMs are at conversation because the prompts there were super, super, super simple. They were basically just, you're an interesting thing to talk to. Now go talk. In a real world application, you get much, much, much more sophisticated in the prompting. You build these really long, carefully tuned, versioned, and evaluated prompts for something like a healthcare use case. And that's a whole nother topic. But it's interesting. I think one of the big drivers of all this stuff we're doing today and talking about here is that LLMs are actually really good conversational partners now, and that's unlocking a whole bunch of value. So just a little more on this open source framework we released because I think it's a very valuable tool in your toolkit if you're thinking about how to build this stuff. Our goal was to solve the hard problems from that very first slide, the sort of floating cloud of things like really reliable audio and video transport, plugging into really good fast transcription, how you build these real-time data pipelines, how you do audio buffer management, making it easy to swap between models so you can try out for different use cases, different models, handling phrase endpointing, which is surprisingly hard unless you've really dug down into it. Like, how do you know when the person is done talking and the LLM should do something? On the other side of that coin, when a person interrupts the LLM, you want that to be configurable for different use cases, but generally you want the LLM to stop talking, but to retain state, to be able to sort of pick back up where it left off. You need to do echo cancellation and a bunch of audio processing to make sure that the voice you're feeding into the deep learning models is as high quality as possible so you get the best output possible. And then finally, on the very end of the bot's activity, you need a great voice because really natural sounding voices, as Kane said, make a big difference. So we're sort of talking around this in a bunch of different ways in this webinar, but what can you build? Well, you can build anything that's conversational. You can build speech-to-speech apps like real-time language translation. You can build voice control systems that are quite capable now. So in natural language, you can tell a computer to take action, or you can integrate with legacy systems like electronic health record systems. And what's coming, and just barely here for production use cases that is getting better very fast, is vision models. So you can integrate image processing of lots of different kinds for both industrial and consumer use cases. And that's probably out of scope for this webinar, but it's a really fun thing to play with. These vision models are really impressive.
Nice.
So next steps, just super quickly, if you want to build this stuff, check out Pipecast. It's git.new/AI. Also, Deepgram has a bunch of great resources for this for developers. So there's a GitHub link here. I'm sure we'll drop it in the chat and send it around after the webinar too. And if you're not a programmer, if you're more on the pure product or business side, there are a bunch of interesting and increasingly good no-code and low-code platforms. One of those that I'm a really big fan of, and a company that works very closely with both Deepgram and Daily, it's called Vappy. You can almost drag and drop to build completely capable voice agents on the Vappy platform, and it's worth checking out what they're doing too.
Brilliant. Very good. That was so cool. If anyone's got any questions, please feel free to stick them in the questions in the Q&A there. We've got a couple of questions coming through. There's a couple that I had actually as we went through that there, which is some of the things that have been a challenge for all voice applications over the decades are some of the things that you alluded to there. One is end of speech detection. How do you detect that? Normally, it's done based on an element of silence. There's some other things around semantic mapping that have come around that are a bit stronger. So I'll be curious on how you do end of speech detection. The second is barge in. Barge in can sometimes be a messy thing when people interrupt what the assistant is saying and then start something else. And even the OpenAI demo actually a few weeks back, I don't know if people noticed this, but they were displaying the barge in feature there, and they didn't really get it quite right. There was a few instances where it was a bit messy, so it's quite a difficult thing to do. And then the third thing is latency. So you know, in a natural conversation, it's a bit different online, but in a natural conversation, a 300 millisecond kind of delay between request and response is natural. With large language models, they take a lot more compute, so there can be more latency. So maybe we can start at the beginning, and we can go from the first kind of thing is end of speech detection. Now, can you share a little bit more in terms of how you approach that and the importance of getting that right?
Yeah, we lean on a piece of the semantic detection stuff that Deepgram does and add to that a configurable silence detection or voice activity detection and mic level detection. So we get speech confidence ratings from Deepgram, and then we balance how confident we are that we had a good piece of speech with mic level, like a moving average of mic level, so we can sort of reject background noise and work in a really wide variety of real world settings and silence. So when you put all those things together, and I can send you a pointer to the code since it's an open source implementation. When you put all those things together and you get the sort of configuration knobs right, you actually get really good, reasonably fast speech endpointing. The other piece of that is it's related to interruption handling. It turns out if you build these pipelines with the right abstractions, then you kind of get 1 + 1 = 5 in terms of functionality. So what most of our production customers do is they set the kind of silence window very short, like 150, 200 milliseconds, and then you immediately start firing the rest of your pipeline. So you start inferencing from the LLM. But then if the person continues talking, you cancel that job you just started, throw it away, and reappend all the transcription to the previous state. So if you have really good interruption handling, you also have this sort of powerful lever for really fast accurate phrase endpointing. And putting those two things together was sort of a big unlock for us in our sort of abstraction layer in our framework. With that said, we're still always all struggling to get the latency down to where we really want it to be today. And it's getting better and better very quickly. My rough rule of thumb is if you're down below 800 milliseconds total, for most users and most use cases, it feels pretty good. You really love to get down below 500, but 800 is actually pretty good. And if you add up the transport over the network, the jitter buffers sizes that you need, the time it takes to do the transcription, the time it takes for the LLM to do the inference, the beginning of the voice generation, and the transport back to the user, with today's very best technology stack, you can get down below 800 milliseconds. You can't quite get down below 5 with the best models today, but we're on our way there.
And that must be a big consideration for you, Scott, in terms of obviously you don't want to be a bottleneck in that whole latency factor. So I wonder whether you can speak to us a little bit in terms of how you approach, the speed and that kind of stuff of Deepgram, because I know that's a real thing that you work really heavily on.
Yeah, I think Quinn brought up some great points there. It's not just the models, it's the transport. It's also calling out to other tooling. It's all these things add up. For instance, even if the speech to text were literally no time at all, it was infinitely fast, you'd still have probably 600 milliseconds or just maybe 700 milliseconds of latency. And similar thing for TTS, but this is what we I think this has been a really big challenge for a long time, and this is the thing that we put first at Deepgram, even higher than accuracy, as weird as that may sound, because it's a scalability problem, it's an interactivity problem. And what I mean by that is when we released our first models, 7, 8 years ago, they were on par in accuracy compared to Nuance and others like that, but they were about 1,000 times faster. And we could have made them way more accurate at the time, but we're prioritizing the speed, and we're holding ourselves to that very, very high speed bar. As we then increase the accuracy over time. And I think that's a really important way to look at different speech services. Most speech services first prioritize accuracy, but not the speed. Or like in the case of TTS, the expressiveness and not the speed. It's really hard to get yourself off the parameter count drug or the complexity drug, in models, if you start with the super expressive one that is super slow and really costly, and then now you want to make it very fast. It's a lot easier to be disciplined the other way around. It just takes a little longer to get what you want. But once you do get what you want, then you have world-class accuracy, world-class expressiveness, and then this extremely fast model. And I think this is why a lot of the services that, if you look out there today, like the orchestration layer for voice AI agents, almost everybody uses Deepgram for at least speech to text, because the low latency in real time is just, it's unbeatable. But why is it? Well, it's because we put in that 8 years of effort to have amazing accuracy and a really low latency. So yeah, it's the latency part is a very big deal. The and model speed is a really big deal. We're always working on it too, and we're also coming at it from that perspective of we're going to keep the latency low, but we're going to continue to make the accuracy higher too. Some of that comes from just more compute power, meaning like every year or two, GPUs, double or get 50% faster. And so therefore you can have bigger models and that kind of thing. That's one thing that you can rely on. But others are just, more ingenuity and in the underbelly of making these models actually work. And yeah, so yeah, it's really important to us.
This focus on latency is one of the big reasons we've worked with Deepgram so long and valued it so much. When you're routing audio and video packets for real-time communications around the internet, you're naturally obsessed with latency. I dream about latency at night, and how to, cut 10 milliseconds off of a network route. So
Yep.
the fact that Deepgram can deliver these kind of audio or natural language processing packets to us very fast has always been very, very, very important for the way we think
Mm.
about the world.
Yeah, and I
Mhm.
suppose as well, I don't have any evidence to back this up, but I would imagine that because large language models have a lot better capabilities around understanding language, they can deal with spelling mistakes far greater than a traditional NLU model. So before it used to be that if you had a speech recognition system that got something a little bit wrong, you say house, but it pronounced it mouse or nouse or something like that. And therefore, what you would do is the text you would feed to your NLU model would be incorrect, and therefore, if it doesn't map it to the right intent, it's because of the speech recognition. Whereas,
Mhm.
not that there is as many issues, because it's deep grammar is known for being accurate and fast. However, there may well be cases where it doesn't get it exactly spot on absolutely every single time. But I think that now that there's large language models that have got far greater language understanding, again, I don't know if this is provable or not, but it seems to me at least as though those odd issues here and there where it might not transcribe exactly 110% might not actually be as big a deal. So the speed really becomes then top trump in that situation, doesn't it?
Yeah, it's definitely true. And even if you look at text input to language models, we have typos, but still they answer usually, the way you would want them to. So yeah, there's always going to be errors. Actually, it's kind of interesting if you take even like highly trained professionals that have been doing transcription for 10 years as a full-time job and are, just pros and athletes at this. If you sit them in front of a computer and give them only real time to listen to audio and then to type, they'll get about 85% accuracy. If you then give them a infinite amount of time to type it up, think like 10 hours or something like that, they'll get like 97% accuracy, 98% accuracy. It won't be 100%, and this is if you have another person check it, maybe it'll add 0.5% of accuracy and another person, et cetera. It's like it's never perfect. But I think a good way to look at that is through text input as well. Like if you just go use Chat GPT or something like that and have some typos or use the wrong word or a homophone of a word or something like that, then it still knows what you're talking about and continues on. And so yeah, it's a very big help to the entire system.
Same thing for natural translation between natural languages in real time. We're a lot of customers who are exploring using GPT-4, for example, to translate between, say, Spanish and English. And they're really worried about the accuracy of the translation. But then you test it against a human translator, it's there. And that's a little bit counterintuitive for us because we're all still catching up with kind of what the capabilities of these large language models are. They're not good at everything, but they're good at some things we don't naturally expect them to be good at. And so, for example, in the healthcare setting, there's a lot of concern about kind of regulation around translation being accurate in a medical setting. That's going to take a little time for people to work through and get comfortable with. But we've done the testing, and you expand access massively without reducing accuracy by, say, using GPT-4 instead of a human translator.
Mhm.
Brilliant. Yeah, I never thought about the fact that humans get it wrong as well. It's like the fact that we've got machines that can do this at such a scale. You could be
Mhm.
having 10,000 conversations at the same time using the same technology and it will do it. It's massively impressive. Um, I want to get on to some of the I want to show some of the voices, and then we've got quite a lot of questions coming through from people. So I think it would be good to get to some of these questions because some of them are really good. So with a voice user interface, as well and good as the AI agent component needs to be, because that's the brain essentially, the whole thing's pointless unless it can do something that you're asking about. From a user interface and from a user experience perspective, though, in a voice environment, the voice that comes back is all you have. They don't see the complexity behind the prompt engineering. They don't understand what models are being used. They don't know about latency and stuff like that. All they do is talk, and what they get back is a voice. Now, that voice needs to say the right thing to answer the query that they've asked. And really importantly, it needs to be accurate. But the experience element comes from the voice itself, doesn't it? And, we've all heard those, the kind of voices that will say something like, where there's a tone shift, like, if you would like customer service, press one. It's like being just patched together from loads of different recordings and stuff like that. And then the early versions of text to speech were kind of okay. You could get away with it. Some of like Google's early voices and stuff like that, they were all right, but they're not really expressive. They're not very natural. But now I mean, the voices that Quinn showed there, one of them had like an Irish twang to it, which was really cool. So now they're super expressive, they're super natural, they make the experience far better. And I think this is a part that's really overlooked when people come to designing these kind of systems. They think, well, I'll just grab an Amazon Poly voice or something like that. Whereas really, the experience is in the voice. And so you've sent us over a couple of examples. I want to kind of play a few. But before I get into that, I don't know whether Scott, Quinn, you have any other thoughts in terms of just how important one the voice is, and also the improvements that have been made to synthetic speech generation over the last kind of half decade or so.
Yeah, I wanted to add one thing, which was really surprising to me that that this happened so quickly. I'll explain it briefly. In December is when we first launched the preview for our TTS, and November is when we were doing the testing ahead of that launch. And we didn't know we didn't know how the voices would perform relative to other fast voices. So think like Azure, AWS, Google, etc. We literally didn't know. So we just did a scientific test. We found random folks and played them different voices. They didn't know who was what. It was all played randomly, and that kind of thing. And the voices, our first version of the voices, V0 of the voices, won over 90% of the time, from
Wow.
an expressiveness perspective. And now I'm not saying the voices are perfect yet. They're not perfect yet. Like I mentioned, we prioritize latency. And so if you want to have super low latency, you have to give up a little bit in expressiveness right now. But compared to what folks were used to using even 6 months ago, it from a human experience perspective, it's 95% plus preferred now, even the low latency voices. But yeah, we released those in December and then have continuously improved them, and then went GA in March. And so yeah, I think Quinn, you played a demo from a few months ago. If you listen to the voices now, they sound even more natural. And I think, Kane, that's what you're about to play.
Yeah. So I do have some samples here. Let's give some a go, shall we? So here's one example here. Let's see if you can spot which voice is the actual synthetic voice. All right.
Excellent choice. So I have two classic burgers, medium well with cheddar cheese, one large fry, and one vanilla milkshake. Will that be all for your order?
So that was actually just one. So it was fairly obvious which one that was. But that was good. It had pauses in the right place. It was fairly expressive. Let's take another one.
Hi, this is Carly.
Hi, Carly. I'm calling from Ocean Cruise Adventures. I hope you enjoyed your stay. Can I ask you a few quick questions on your experience?
No, I don't mind.
Thank you. The first question, on a scale of 1 to 10, how satisfied were you with the experience?
Probably like a 7.
Thanks for that. Were there any parts of your experience that were exceptional?
I would say probably the service, like the customer service was pretty good.
Thank you. We definitely pride ourselves on that. You mentioned a 7 though. How can we improve your experience?
I felt like there could have been more variety in the food. There just wasn't a lot of options offered.
I'm sorry to hear that. Let me mark this down. Well, let's see. Those were my questions. Is there anything else you'd like to share with us?
I don't think so. I think I was pretty satisfied with it overall.
What's interesting about that there is that two things. One, there were some disfluencies in there, which is I'm sorry to hear that. And so that's interesting. And then the second thing is that there was some expressiveness from the perspective of, at the beginning of the conversation, the voice was a little bit more like, thanks. And then when he said, and then you have a 7, can you tell me more about that? And then the lady responded, it could have been better. Then when the voice came back and said, I'm sorry to hear that, it was a little bit more toned down, a little bit more empathetic. So I wonder if you can share us a little bit. I've got some more to play here, but before we do that, how do you get to that level of expressiveness, and how do you control those disfluencies? Is it random? Is it based on the text? Is it something you control programmatically? Like, how does that kind of work?
Right now, it's only based on the text that you tell it to say. And so from some of the text that was spoken, you could guess that like when somebody says I'm sorry, they typically, would say it in a more apologetic way. And so then the model can figure out that that's what it should do. However, this is not like the future. The future is you give metadata to the models. You prompt them. You make your speech to text promptable. You make your LLMs promptable like they already are, and you make your TTS promptable. And you chain together all of the different prompts and contexts through these different models, so that when the LLM outputs the text that it needs to be spoken, it also outputs a prompt that says, I need you to say this in an excited way, or I need you to say this in an empathetic way, or, speak this slowly so that it's easy for folks to understand, etc. And this is coming in a future update from Deepgram. But I think that overall, you can get context from the text that is supposed to be spoken already. There are certain things that you can't, like just the word great, how should I say that, great or great or whatever, you don't really know. And this is why like the extra context is so important. And actually that is really the gap to making it the most human-like. It's not really a model capability. Like these models can be really expressive. It's really chaining together all of the context, and then when you get the context right from the beginning of the conversation, I'm not even talking just on one turn. I'm talking about all the way from the beginning of the conversation into where you are now and to the end of the conversation, etc. Then that will actually make us feel like, wow, I am talking to a human. Like there's no way I could tell the difference, and it's going to be through context. So anyway, the current version of systems doesn't have the sort of infinite prompt ability. It comes through the text that you're asking it to speak right now.
That is really interesting. And the ability to prompt it further would be really interesting, because that would then negate the reason to use speech synthesis markup language, or SSML as it's known, which is, for anyone who's worked with it, is an absolute nightmare. It's like HTML for voices. You've got to mark up every single word and how you want it to be pronounced and whether you want it to be pitch shifted, or it's just a total laborious task,
Yeah, I think there will be some kind of, there are certain things that you will want to have direct control over. And I think most folks using a service, and also us, we'll prioritize having some control in that way. It may not be exactly that markup language that people are used to, though, because of what you just mentioned, that you have to go through, you don't want to have to specify everything. You want it all handled, 95% of it handled just by the context. And then maybe a few specific things you go in and say, like, really, when you're giving an order number, I need it spoken like this, and I don't want you to infer how you should speak it. It needs to be done exactly this way. That's okay. And that should be supported as well. But I think that experience of having to mark up every single thing and then trying to fill slots and that kind of thing, forget about all that. It's going to be much more contextual.
Yeah. You need things that are handled globally as well, doesn't it? I remember one time we worked for a brand, and the text to speech always mispronounced the brand name. So we
Yeah.
had to use SSML, but they're like the alpha phonetic SSML,
Yeah.
where you're
Yeah.
telling it how to pronounce something
Yeah.
and the sound it should make. But we had to do that every single time the brand name was mentioned manually in line. And it was just a nightmare because you're bound to miss something. So a way of globally saying, whenever you pronounce any reference numbers throughout, pronounce them like this. Whenever you pronounce this brand, pronounce it like that. Setting
Yeah.
that globally would be a dream.
Yeah, I always have to be careful about talking about the technology side of this, because what I'm about to mention is not necessarily a product that's available yet. But uh, there are certainly ways to make a system aware of the fact that it may be pronouncing something, or maybe think of this from a human perspective. Sometimes you see a word and you're like, actually, I'm not that sure how to pronounce it, but I'm going to pronounce it. And for a TTS system, it actually has that kind of confusion state inside it. And you can extract that and find moments where it's confused about its pronunciation. Nevertheless, it still pronounces something. It doesn't just give up, but you can take those instances and map those to this is one of the the beauties of doing speech to text and text to speech, look for examples of audio where that word was spoken in speech to text land, in true audio, and then say, hey, how are most people saying this, and then filter that into the TTS model. It could be from an IPA pronunciation perspective, but it could also just be from a listen to that audio, listen to how they just think. I think the best way to think about this is, what does a human do? A human listens to somebody else say it, and they say, oh, well, maybe I should say it that way. And these models, this is what's being worked on behind the scenes. Active learning is what we call it internally. And then these models that can get context from other areas, they can get audio context, they can get text context, you can give them IPA, phonetic spellings, et cetera, and then you can control it. But I think a really good way to think about this is it's a continuum. If you, in that instance, you notice that brand name is incorrect, you should have a spot where you can go and say, hey, this word in this context, it needs to be pronounced this way. But now that's a really strong signal to the system to go investigate that in the world more and say, hey, I should look for other examples of folks saying that. I should come up with alternate pronunciations, and I should send them back to you, the user, and say, hey, is this okay? Is this okay? Is this okay? Just like somebody learning a language would say to you, and you're like, yeah, that's great. It's a perfect pronunciation in that situation. Now it has training data that it can go back and update its own internal, update that model, and then it will just always get it correct. And I think this is the experience that most people want, that, it's not a perfect system. It's a system that can learn. And that is the promise of artificial intelligence, is systems that can learn just like humans do, and do it through a natural interface that we're all used to using. So that it's going to be here very quickly. I'm not going to say, like, 3 months from now or 6 months from now we're going to release that system, but certainly 2 years from now, 5 years from now, we're going to be talking about a fully connected textualized system that everybody's like, whoa, this works just like how a human would, but even more precise and faster than I could imagine.
Brilliant.
As somebody building the application layer on top of these amazing technologies, I'm really looking forward to that longer context, or context at all. I mean, one of the things that when you onboard somebody as a programmer to building these systems, it's always surprising to them, is there's no state at all in any of the LLMs now. You at the application layer have to maintain the state. You send the whole conversational state every time. In some ways that gives you a ton of flexibility, but it also means the LLM doesn't do any remembering for you. But the LLMs are so good at long context, you really want to sort of feed it the whole context of the conversation every time if you can. That has cost implications, though. It has latency implications. So you have to find this tricky balance now. And on the output side, correct me if I'm wrong, Scott, but I'm not aware of any synthetic voice systems that do anything other than just the context you gave it in that moment. And it would be a huge unlock for us at the application layer if you could cache the activations for us, and we could just sort of stream the text to you in a stateful way, and you'd have that whole context every time you emitted a new sentence. So I'm looking forward to that happening.
Yeah, my comms team probably right now is thinking, probably shouldn't have said that before the announcement. But nevertheless, yes, that type of thing is coming, but I think it should be expected.
I think it's good to tease things before they let's a startup founder thing. Like, it's okay to talk about what you're working on. It's exciting.
Yeah, this is really going to be the unlock. I know when folks listen to conversations now, two bots talking to each other, or a bot and human, and you can find little quirks and whatnot, and you're like, okay, I get it. This is a bot talking to a bot. Maybe it's a latency, maybe it's other things, maybe it's just the tonality, or certain things that make you go, what? But those are going to diminish severely once you can pass context all through it. So yeah, Quinn, you're right on.
Nice. Cool. So I know we're at time now. There's still 3/4 of the people that were started out watching this and tuning in are still here. We haven't got to any questions yet. So if everyone's happy to hang around for maybe 10 minutes, we can get through a couple of audience questions.
Yeah, I am. Yeah.
Cool. Is that all right with you, Quinn? Yeah, that's good. Thanks for that. So Alexa, on your team, Scott, has been responding to a couple of questions here and there. So thanks for that. And we'll get to a few here, because there's a few things in here that we've kind of touched on but really haven't double clicked in. So the first one, which is from Anonymous, so apologies I can't give you a shout out, which is, when will languages other than English be available? Speech recognition and presumably text to speech?
Sure.
Is a multi-language available now or no?
Sure. Yeah. So for Deepgram, we support over 30 languages and dialects right now. And for folks who have been Deepgram users, they might know that our latest model architecture didn't support all languages. But I think within a week or two now it's going to. So those will be all rolled out. The text to speech still officially is English only because we haven't announced the support for the other languages. But talk to our product team if you want access to a few of the others that are getting rolled out right now. I know Japanese is one of them, etc. But yeah, so TTS though right now officially it's English only. Yeah, we'll be supporting. We want it symmetric, right? Whatever we support in speech to text, we'll support in text to speech. It takes a little bit of time and automation and everything in QA and everything to get those systems fast and accurate and expressive and all of that. Look out for that certainly by the end of the year. But yeah.
Nice. Another question here, which is from Ken. Ken's put this in right at the beginning, which so we'll definitely want to get to this one, which is the voice AI agent that can interrupt you. When will we have a voice AI agent that could interrupt you based on confidence that it already knows what you're about to say? It seems that low latency alone isn't enough to make you feel like you're talking to a real person, but allowing the agent to interrupt like real people do would be really compelling. Is that a potential use case, allowing the agent to interrupt the speaker if it knows what the speaker's going to say? I don't know if that is borderline rude from an interaction user experience point of view.
I think that should happen. There are cases where you want somebody to say, "Let me stop you there," and here's a response. But I'll tell you one of the fundamental limitations right now is the LLM is typically the slowest part of the stack. And so folks only want to run it once and not incur the expense and latency of running it over and over. And so that typically means that at least systems built right now will wait for the person to stop speaking before they send it off. That doesn't mean you have to, though. So right now you could take the code that Quinn put up and you could slightly modify it. It's not a big modification, just an async thing that fires off LLM calls. But if you do that every 100 milliseconds or every 500 milliseconds or every whatever, like you'll say, whoa, my LLM build just went up like 10 or 50x. And I just added a whole bunch of latency to the system. So that's like the technological reason why it's not done right now, but you actually could do it. Yeah, Quinn, anything to add there?
Yeah, we built some toys that do that with a really small, fast model. That's you can run on a inexpensive cloud GPU or whatever. And it was really fun to build that. I'll dig that code up and I'll post it. It is a technological limitation in terms of cost. I also think for most of the use cases today, you probably don't really want the LLM to interrupt users. But as we go farther down this kind of use case broadening, I'm sure there will be a need for that.
Yeah, there's certainly the 80-20 rule, works out here. Like just don't interrupt and it'll cover certainly 80% or more of the cases right now. And it makes it easier, but it only takes 20% of the effort right now.
Yeah. Question from Atish. What would you say, based on that pipeline that you showed earlier, Quinn, what would you say is the most time consuming part of that entire process?
Well, it depends on whether you're trying to build it from scratch entirely yourself. I think there are like half a dozen things that are super time consuming if you're trying to build it from scratch. But if you're building on top of a really good abstraction layer, the big challenge now is how do you prompt the LLMs? The LLMs are so capable and so flexible, but also so futzy that to get a voice agent into production, if you can, what you should do is spend almost all your time trying to figure out how to prompt the LLM as well as you possibly can.
Which is pure natural language, so not coding and that kind of thing. So like many people can do that. And actually, I wanted to just shout out Quinn's code and the code that we have that you linked, Quinn, for building these systems. I would not spend a lot of time. I mean, don't get me wrong, it's fun. Like if you're that person who wants to roll up their sleeves and figure out what this is really about, start from the beginning, integrate the speech to text and the real-time callbacks and all this stuff and try and figure out how it works. You'll probably get to a point though where you're like, whoa, there's a lot of stuff here. It's frustrating. It's really annoying. It's taking days. It's taking weeks, etc. Then go pull Quinn's code or others and just get something that definitely works and start editing a few of the things, because there's a lot of gotchas that have been figured out, already in this code. So yeah, that saves so much time, and then you can focus on the prompt, like Quinn is talking about here, where you get that experience to be really good, and then maybe you can add in, your interruption if you want it, right, and others, and so if you're budgeting your time for development, that's certainly how I would do it.
Yeah, I mean, because I have this conversation so often with developers who are just trying to get started with this stuff, I think it is worth maybe naming those things. So almost everybody starts, if you're a general purpose engineer, you haven't built this kind of stuff before, you start with a WebSocket, and then you plug some audio encoding library on your native on whatever platform you're doing into that WebSocket. You send the audio over the link somewhere. Then you call out to Deepgram for transcription. You get the transcription back. You try to figure out how to do phrase endpointing. Phrase endpointing is, as we talked about before, like surprisingly subtle. You get that to the 80/20 point. You feed the stuff to the LLM. Then you're in prompting land. Great. So you're spending a bunch of time on the prompting. Then after the prompting, you're calling out, say, to Deepgram to get audio frames in real as close to real time as possible. You're managing those audio frames so that you can feed them to an audio encoder with no gaps, so you don't get any popping, you don't get any pitch shift, you don't get any weird stuff around audio. You probably got the audio Indianness wrong because you probably built on a Mac and then you deployed on Intel machine into the cloud. You spend a day, if you've never done audio processing before, you spend an entire day trying to figure out the Indianness thing because there's no piece of code that tells you, and then you ship back over your WebSocket. You do some testing. Great. After you do the testing, you deploy to a few people. Oh, their WebSockets implementation doesn't quite work the way the one on your platform does. Okay, now you're building timeout and reconnect logic. And sometimes there's like a lot of latency in the system. Okay, you're trying to figure out where that comes from. What comes from the fact that WebSockets aren't the right protocol for sending audio over links with packet loss. Then you're like, okay, well, now I have 1,000 users, but 100, 10% of those calls don't work every day, but I don't know why. Now you're trying to build observability tooling. You're trying to build audio pipeline observability tooling on top of WebSockets. There's no tooling for that. Like it just doesn't exist because it's not the right way to do it. Then you're trying to figure out why on some platforms echo cancellation doesn't work. You can't ask your users to wear headphones, so you have to figure out echo cancellation. Now you're like on problem 6 of probably 15 of these problems that you have to get to. And then by the end of this, even if you wrote all that stuff, what you're going to find is you have to put servers very close to the edge of the network to get the last latency drop that you really want for production use cases. Because if you send a packet from New York to San Francisco, it takes like 50 milliseconds. If you send a packet from New York to San Francisco on the fastest possible backbone link, takes maybe 30 milliseconds. If you send a packet on like that 50 milliseconds average, it's a very broad curve, and you might be at 200 milliseconds for some of those packets if you're just routing over the public internet. So now you're deploying as many servers as you possibly can in as many availability zones, probably on multiple clouds, to get all the way to like production scale. So I think it's great to build this stuff from scratch. I'm a tinkerer, and I think everybody should try to build it from scratch. But if you're building a product, you probably want to build on the kind of layers. Just like I don't build speech to text models, I don't think every engineer building a product wants to build the whole stack.
Yep, and we don't develop GPUs, or memory, and so
yeah.
But all those things are fun. I would love to.
I would love to do all of them.
Do an FPGA GPU.
Yeah.
Nice. So another question here is from John. Quinn, you kind of alluded to some of it. Well, at least one way of doing it. My curiosity is in the speech, the middle part. So you've got the speech to text in the middle. You've got the AI engine. Sorry, speech to text at the beginning, AI engine in the middle, text to speech on the back end. Conversations with our AI is generically not necessarily difficult in concept because it's input output, but the difficulty is in understanding where to put the business logic. So that healthcare example you shared, Quinn, there's a very specific format for that conversation. Specific questions have to be asked, specific information has to be gathered before you can move on to the next question. John's question is, where does that business logic sit?
Well, there's two things to say about that. One is that's where the leverage is for every product. So as we roll this stuff out into the real world, domain specific knowledge, like vertical solutions, there are just going to be so many of them like that. That's where people are going to build great products. And the logic lives in the cloud, in the wrapper for the bot, basically, or in the bot, depending on how you think about it. So you want to get the audio to the cloud, and then you want to have your bot code and have the business logic, including the LLM prompt, all sort of in one place. Do everything there in that process running in the cloud in this little envelope that you control, calling out to whatever services you need, and then sending audio back to the client. Does that make sense?
Mm-hmm. Yeah, John, if that doesn't make sense, ping us. He said he experimented with Dialogflow as well. It kind of works well, but it's quite time intensive essentially.
The prompting is tricky, and everybody who's deploying these applications, these LLM centric applications, whether they're real time or not, is climbing up the same learning curve together. How do you prompt effectively? How do you do evals so you know whether your prompts work over time as you swap out models or as your user population changes? And how do you pay for LLM usage at scale, which might involve using models that aren't, say, GPT-4 for some use cases, or a mixture of models. Those are sort of the three big things everybody is talking about, other than latency, which Scott and I will talk about forever because we love talking about latency.
Yeah, and shout out to some of our partners, like Vappy, like Retail, like others. There are places that you can just go sign up. There's a flow. You select which speech to text. You select which LLM. You select the TTS, and then you put in a prompt, and then you call a number and talk to it, and that, or just do it right there in your browser, and then you can test that way. That's a fairly robust, really quick way to like just get into sampling what is possible. And then as you get more specific, you'll have this like function calling that you need to do. It's not just a prompt and talking. That's nice and everything, but I need it to go do something. Okay, well, there will be a connection there. And you might need to go more, more bespoke for that right now, at least, because a lot of these companies are like a year old or less, so like they don't have all the functionality that you necessarily would want. If you can wait, you might want to wait a little bit because some of them will definitely be coming out with this. The development is going so quickly. If you can't wait, then you just start building that stuff yourself, but build it in a way that it's robust and interchangeable enough that if that platform starts supporting the type of function calling and that kind of thing that you need, then you can switch to that. Because it's an extremely important part of it. There definitely are use cases where you just want to talk with the LLM and you want to learn, like education is one of the biggest ones where there's a whole bunch of knowledge inside it. I don't need it to go out and talk to the web. I don't need it to do any of these things. Just tell me about how Rayleigh scattering works and like why the sky is blue, and like let's go down that rabbit hole, right? That's okay. But if you need to fill in a CRM or something like that, well, then you need function calling out to these other things, and you need to build some interface. It's not terribly difficult to get some of those things to work. It just becomes more complicated when you want all of it to work all the time, and and everybody's building that infrastructure to make that real today.
There are a couple other pointers that if you're just starting with this stuff, you might want to look at. So these are not for the real time. These are for the prompt engineering and tooling orchestration. LangChain and Llama Index are both starting points. A lot of people kind of use as entry points to understanding the whole sort of LLM flow stuff. And I believe Vappy supports like LangChain and Llama Index as kind of envelopes around the LLMs. We just had a community contribution of LangChain for PipeCat. So I think that merged last night. Those are super useful ways to sort of start to understand how to use the LLM effectively.
Yeah, a lot of folks might hear or might think of the LLM as like you give it one input and it gives you one output. That's not necessarily how you have to use it. You could feed that output into as many LLMs as many times as you want in order to like reform that response. Now, it adds more latency, it adds more complexity, it adds more cost, but nevertheless, it depends on what you're trying to do. If you could wait 2 seconds or 5 seconds to like really format it correctly and make sure it's 100% correct before you make that database database entry, that's okay. You could put some filler in there with the TTS saying like, hey, let me calculate that and just hang on a second while I do all this work and then do this in the background, and then it goes and does it. So yeah, there are ways to hide the latency, just like we do with humans. Again, think what would a human do? But anyway, yeah.
Yeah. I will just mention one thing, John, which maybe just fills one slight gap here, is that what we're discussing here is having those conversations running through large language models natively with pretty much nothing else. So as Quinn said, large language models don't have memory. So one way of doing it is that you feed everything into the large language model. So your prompt will consist of what the business process is, what the conversation should be like in an ideal world, an example of the conversation that's in the middle of happening, and then it will ask it to kind of go from there. There is another way of doing it, which you pointed out, Dialogflow. Is Dialogflow a good tool, you've asked? Dialogflow is, all of these tools are good tools if you can use them correctly. The thing with Dialogflow is that historically, Dialogflow is a natural language understanding platform. So it's not necessarily an LLM based application. It's integrated LLMs into it more recently because it kind of has to. But Dialogflow is traditionally a traditional machine learning natural language understanding system, like there's lots of others out there. The benefits that you would get from using Dialogflow is that you would have more rigid control over the state and flow of the conversation. And if I was to use Dialogflow in conjunction with large language models, I would essentially use a traditional NLU model for some obvious basic intents, and I would throw out to a large language model for the language understanding part, classifying that intent, and then bring it back into Dialogflow for the managing of the conversational engine itself. And there's a number of other platforms out there that do things that are very, very similar to that. So there is a different way of doing it. You can use the large language models to do the entire thing from end to end. I'm yet to actually see a production version of a transactional use case that uses LLMs from beginning to end for all of the APIs and all that kind of stuff, all of the state management, context management, and everything like that. I know LangChain is kind of getting there. They've got features around memory management and stuff like that, but I'm yet to see a production case where that happens. All the production cases I'm seeing is more using tools like Dialogflow, Amazon Lex, Microsoft's got very similar tools, IBM Watson's got very similar tools. There's some other companies around like Core, Cognigy, VoiceFlow, Browser. There's a whole bunch of others, more traditional machine learning platforms that have integrated LLMs that do more of that kind of workflow building, that use LLMs for very specific stuff rather than using LLMs for the whole end-to-end stuff. So it's all about the use cases that you've got essentially, and what tools are best to kind of enable that use case,
Yeah, if you wanted to make an educational app where you could ask about anything, like Dialogflow is probably not the thing you want to use, right?
Yeah.
Like it's a very rigid, like kind of tree based, or like evolve from a tree based way of thinking, etc. That one you definitely want like a very LLM centric thing. But if you're purely doing data entry, like purely, and that's it, and it doesn't need to be conversational, doesn't need to be open ended, etc., then Dialogflow is probably your guy, and so. And if you need to blend the two, then there are creative ways to blend the two right now, as you mentioned. So yeah.
What I'm seeing a lot of is that for information-based stuff, people are using retrieval augmented generation because it's better, because you've got a lot more breadth. You don't have to map out intents for every single question. This is, by the way, this is for like an enterprise use case, like a call center or something like that.
Yeah.
So retrieval augmented generation lets you cover a lot of breadth, lets you ingest a large amount of data, benefit from the language model's understanding, and you can potentially generate content if you want to, or just regurgitate. For the transactional stuff, the kind of like business process stuff, that I'm seeing a more of a blended approach where it's more of a rigid flow that's being designed, because this is the steps we need to go through, with large language models supporting that for classification and kind of what we call grounding, which is anything that's not understood natively by the model. You throw it to a language model and say, what does this mean? And then maybe you use it for like generating some of the responses, but you would write the responses that you expect initially, and then you would have the language model contextualize it based on the previous turn. And so if someone says, I'm looking for some car insurance to put my daughter on my insurance, the large language model can be used to say something, oh, great, I'm glad you're trying to get your daughter insured. Let's get you moving, sort of thing. So as I said, it's lots of different ways of doing it, and it all depends on the use case you're trying to
Yeah, just get started with something simple though. Like what we mentioned, you can in 1 minute have a bot going with some of these platforms, and just start messing around with it. And but you'll start to run up against these, I need to call out to something, or I need to interface with a point of sale, or I need to interface with a database or something like that. Okay, well, those tools are coming. Some of them are already supported in different areas, but this is also just like the state of the art is evolving very quickly. That problem that you're running up against will probably be solved in 3 months if it isn't solved now. But yeah.
Definitely. Cool. Thank you both very much. I've just put in there again the links that you shared earlier, Quinn. If you want to go and get started and try this stuff today, git.new/AI. You can go and check out Pipecats. There's a link to GitHub there where all the code resources for the Deepgram transcription text to speech is in there. We've put a link in there to vapi.ai as well if you want to give that a stab and give that a go at building the voice bot. If you want to find out a bit more about Daily, it's daily.co, DAILY.co. Put that link in there as well. And if you want to integrate Deepgram into something else that you're doing, then you can go to deepgram.com and you can learn all about that there.
I want to shout out Quinn too. He has great blog posts about putting all these things together. So go check out some of the blog posts he's written.
Good idea. I've got one handy actually, which is how to talk to an LLM with your voice. I'll put that one in the chat just there. That was a really good one. I was reading that earlier. Brilliant. Thank you so much, Scott. It's been an absolute pleasure again, my friend. Quinn, really, really great spending time with you. Thank you both so much for coming here and sharing that knowledge and helping to take us forward in terms of how do we take these text-based models and these text-based AI agents and put them into a new environment, make them more accessible, make them more available, make them more useful, uncover new use cases. And it's been a really, really great deep dive session. Thank you for joining us and thanks for sticking around as well for a bit longer. Appreciate it.
Yep. Thanks for having me.
Both.
No worries. Thank you all for tuning in as well. We've got over half the people still here, so maybe this was a good one. I would suspect that it was. Thank you all for joining us. It's been an absolute pleasure. Go and check out those links. We will send the recording around to you tomorrow, so if you want to rewatch it, then you can rewatch this tomorrow. Send it to your colleagues and all that kind of stuff. And yeah, we'll see you on the next one. Thanks again.
Thank you, everyone.